Thank you for inviting me. I'm really sorry and impressed because what I will show you are real things. So for all the students, mainly the students here I'm talking to, when I was at your place, I imagined a lot of three-dimensional structures and all kind of structures. And now I'm in the real life, and I thought that I should introduce you to some of the projects. We are, I'm told, maybe we. It's okay. The main thing I'm proud of is that I'm teaching in the School of Engineering and in the School of Architecture, and we did a special master called Structure and Architecture, so that the students from the School of Architecture can become engineers, and the engineers can become architects. So I'm not here to oppose those two worlds, but to link them together. And I hope it will go further in this direction too. Okay, so let's begin. I was trying to work to show you just real projects about two aspects. One is the art of folding, and the second one is the art of making holes, breakthrough. So you know more than I do that this idea of folding is linked with the idea of inertia. So the first project I'll show you is a project we've developed on this aspect, especially this aspect, the aspect of the palm. And then we'll talk about the idea of breakthrough, the idea of making holes. As Laurie Collet said, Laurie Collet was the main developer of 3D structure in the 50s of last century. The art of placing the void is more important than the art of placing the material. So we are trying to come back to this idea. The first project I'll show you, don't be upset about the idea that it's real. Huh? The first project I'll show you is the station we did in the south of France, which is a link between Montpellier and the sea. This is the railway station, and the main idea was to link a new material that we've been developing for 40 years in France, which is béton de fibre ultra performant, which is high stress concrete. And we've been developing that for a very long time, but now we are trying to put that in the real project. So for the cover of that project, you see this is the station, these are the railway, and we're going to talk about the cover of that. So we will talk about bridges also, but it looks like a bridge because it has been covering the railway, and we are talking about this cover, which is made of this material. The idea was to make a bridge building, and this building is bridging the railway and connecting the buses, the rail buses that are coming on one way with the high speed train. And the main things we're going to talk about is the idea of light and lightness. How we connect those two ideas. How do we put light on this cover? Is the idea that we are not going to put it in glass. You know, I don't know why all the main structures are made out of glass and steel. It's coming from the 19th century. 1851, when the Crystal Palace made a huge train for everybody. Everybody thinks that we need to have glass and steel. But maybe here in south of France, we need more shadow than glass. And we don't need those high volume because the train are not coming with choke like they did before. Now you know that the train are electrical now, so we don't need this be systematic as it was. So I was thinking about the idea of shadow. Railway station from the south would be under cover through the shadow. So the shadow will be made of the main structure of the concrete, and the holes are in different situations. We'll come back on that later. So the station is covered by those elements. What we did is we transformed the cover so that the wind coming inside the station will permit to reduce the temperature inside so that we have a speedy effect inside so that the wind is coming that side and going on the opposite side. Because of this horn, we managed to do that. New project. Sorry. And we did a wind analysis for all that. So that, I was talking about this. The idea that, so we spray water from the cover. We spray a little water so that when the wind is coming here and going back here, the temperature will go down for 2 or 3 degrees, which is quite a lot. This is the wind analysis, and then the idea of light was the main topic, the idea of shadow and light through shadow. So those elements are made out of concrete. The span here is about 20 meters. We'll come back to that in a minute. And all those elements are made out of 115 elements, all the same, but 5 different molds. This is it. UHPC in English, which means something. I don't know exactly what it means, but high stress concrete. And you see that those elements are covering here from inside and outside. This is outside, a balcony. This is the limit of the building, and this is the inside of it. So it's about 20 meter span, and we have 5 different elements, and each of them are made out of very thin shell. So this is 4 centimeters thick on 19 meter wide, with a kind of rib in the middle where we had to pre-stress the whole thing. Those elements are prefabricated because of there's no steel in it. It's small needles, no steel bars in it. Only one steel pre-stressing cable in the middle. So we had to change and a lot of geometry because of the idea of pouring the concrete, heating the concrete, and also transportation. All these elements are coming from the south of France and going into this part. So what is very interesting, and which is something very special, but very easy to understand, is that for the first time, I don't know if we have another example of that, for the first time we have a structure that is a cover. Usually you have a structure and then on top of it you have something. In that case, the structure is covering because the concrete is very dense, high density concrete, and it has its own waterproofing. So that's why we could, because this material is quite expensive. So we use it as with a very low quantity of material, and also with the idea that we don't have to, no waterproofing on top and nothing, just the concrete, which is very interesting because obviously in that case we have no insulation. We are the inside and the outside, so you can see the concrete from all over, and you can see the concrete from underneath also. So it's a finished structure. It's a finish, and it permits to have this idea of waterproofing and structure together. If somebody thinks that there is another example, I will be happy to see that. Obviously, the structures that are inflated, but I mean, I'm talking about this kind of structure of concrete. And then we work on the perforation of that, depending on the orientation, south, east, north, south, and in different situations so that they will have less light coming from the south than in the north. And then there is another feature which is quite important, is that on top of it, the smoke can go out in case of fire, so we have a protection and it's open there. You don't want me to move?
No, you can wish.
But I'm moving, and my hands also. It's very resistant material. As you can see, we are talking about 130 MPa, which is quite a lot, and obviously it's not working in tension. So we had to reduce the tension by using the pre-stressing. So we did an complete analysis of each, what we call the palm, like a palm tree. And you see the tension is here because of the bending, obviously, in the middle. So in that case, we use that cable inside of it so that we pre-stress it and reduce the tension. What is quite important here is limitation of the cracks in this material. The maximum stress is here in the middle. That's where we put the cable. This is the most interesting thing, is the limitation of the crack width because of the porosity of the material. So we are coming back to that, and then someday we're finishing the calculation, we're finishing all that, and we have to prove that it works. Because this material has not been used very much. It has been used for few footbridges, but not on this case of shells like this one. So we had to make what we call in France a technical experimental evaluation. So we did like all the pictures you saw from Nervi, the Candela in Mexico, and we put stuff on top of it, and we measure the whole thing, and the people were looking at everything and calculating everything, and they accept it. So it's a one-to-one scale test. And it was also a problem of the dynamic behavior of that was quite complicated. And then you have 115 of those elements on site. So it took us a long time to develop the whole thing, but once we had it on the site, we had a huge crane, 1,000 meter, and we put that at the end. It's about 100 meter on 80 meter, the whole thing. So these are the elements. This was the first one. Try. And then we had to put that, because of the cost of the prefabrication was quite high, but the cost of the erection has to be because of the cost of the erection, we had to go very fast. We all did the whole cover in less than 1 week. And then, coming back to the idea of form and force, this idea of folding was linked with the idea of light. This idea of folding was the idea of the inside forces we put in this material. And the construction went quite well. And I'm very happy to show you that because we are linked not only with ideas, but those people that are pouring the concrete, prefabricating, transporting, and then the idea is really linked to the idea of the material too. So form and forces is also directly linked with this idea of experimentation of material. And as you can see, there is a lot of effects on the floor. I was afraid of some people would be annoyed by that, but it's working. Okay. And at the end, some trains are coming. And the people that you see from the outside, they are on the balcony. It was more linked with the idea of the geography. We are not talking about that here, but the idea of the landscape being linked with the mountain and the sea, and showing that this specific railway station is for this place and in relation with this landscape. So, I'm going to talk about some new, we are coming back about the idea of folding, but I was wondering, how we can talk about the idea of breakthrough. I was thinking about the fact that we did that for the palm covering, and we are now doing that on a very strange beam. This is a train, bridge over huge train stations in Bordeaux in the south of France. And in that case, we are working on the idea of a plate that will be maintained with a kind of truss, but mainly with the idea of hold. So if you look at the section, is very strange because they wanted to have a cycle on one and pedestrian on one side, and this is only for buses and trains and cars. So we had a large beam on one side, which means that the slab is going from one side to the other. This one is more rigid than this one. That's why you have this higher part than this one. And we've been working on the idea of how to make the holes in these beams. So it's a lot of work of transforming the truss in the plate, and the plate in coming back with the holes to make it stiff enough. And this was the connection. So we are now working on different projects about the idea of how we can manage to be rational in this idea of making holes in it. And you see the ribs are on one side in this direction, and on the other side they are in the other direction. It's here. So in that case, it's not a matter of shadow like in the railway station, but it's also working that way. And I think that there is a whole art of structure that we should develop on that kind of approach. Mainly, the 19th century was made out of trusses, wired trusses. We are working a lot with Virandel beams. I'll show you in a minute. But coming back to that, this is working like a plate and a truss, which is not really irregular, because you see the diagonals are quite special, and the diagonals are also on the other direction. So this will be an interesting way of developing holes in the structures. This is it. So coming back to what I was talking about, the idea of folding and the idea of coming back to new consideration on trusses, this is the idea that mainly a footbridge is a public space. Footbridge is not just a link from one side to the other. It's a place where people love to be and love to stay, and they are sharing the whole space together. And never forget that the public space is the space that all of us are sharing. It's not a representation of the power. It's a place for everybody. It's it's the most democratic way of showing the space. And in that case, we are trying to develop the connection in between public space and structure. So we use that double folded beam on one side and on the other side. See, one side is like that and the other side is like that. So this is like a balcony on this direction. This is a balcony in the other one. And the whole beam is made out of a Vierendeel one without any diagonal. And it's folded to protect the people also. And there is a law in France, you have to have a protection over the railway of 2.50 meters. So we work on that protection, and we transform that protection in a beam on one side, when it's like that, it's on that side and coming on the other side. And the folding of the beam, which make a special situation because the stressors are developed here in traction, tension, and compression, while they are more bending here. And we are using that for the reinforcement of the Vierendeel beam. There is a huge problem of dynamic, which we could resolve here. And you see the two sides of the footbridge now, which means that the people are getting from one side of the bridge to the other in a direction that is showing one way and the other. You see, this is the protection on the lowest part, this is the protection on the highest part, and then and this is folded also. But this is a beam, which this part will become the beam that you see here. And then we put benches in the middle so that people can sit and look at the river of the rail and the boats of the train. And to my friend, to my Chinese friend, where are my Chinese friends? Some of you. 你好吗? Yongzhou. So what we did there, it was a strange story because the city of Yangzhou had this birthday, and the mayor we are working in China for 15 years now, and the mayor of Yangzhou wanted to build a footbridge in 6 months. So we had 6 months to build that. Actually, I came there because we were not supposed to build a small bridge, but we were supposed to build a 1 kilometer long bridge. But she said, before you build a 1 kilometer long bridge, just make a small one. I have to tell you that we never did the big one, but she said that we have to make it very fast. So in France, it will take 5 years. There it took 6 months. And then I said, Yangzhou is a very famous city because it makes a lot of boats. It has an industry of boats. So I said, why don't we use this industry to build it up? And I wanted to fold the steel. You know, usually the steel is used as members. So in that case, I wanted to use as a plate. And I went to see the industry there, and I said, I showed him an idea of that, and he said, what is that? 70 tons. That's what we use in 1 hour. So it's not very interesting for us. But in China, when the mayor is the chief of the Communist Party, it helps. So she called the guy and said, make it. So we made it, which is a procedure we don't have in France it would have. But it was great. So the idea is very simple. This is embedded here. For those who remember, the moment is here like that, 0 here, and fixed here. So we just took the plate to show that distribution of forces from one side to the other. And it's like a folded leaf of a tree. So this is folded here on one side and to the other. So it comes from the embedment on this part and going up to that in the middle and going back to the other side. This took us quite a few hours to develop that. And this is it. This is not this is the real one. So and the people from Yangzhou are very happy with that because they call it Yushu, which is the palm tree. So this, you know, in China they always want to have a reference. So in that case, they think that I was inspired by that, which is not really the case, but they like it that way. And I'm very happy that they like it that way. So you feel like you are walking on this leaf, which is quite amazing in the case that we are transforming a moment distribution in a real situation. And you see it's like, this is like that. I don't know how they took this picture, but it looks like Tai Chi, you know. I think it's a good relationship. Huh? You. So, using that, we had 5 more minutes? 10 minutes. Okay, so we did, coming back to this idea of folding, we used that on another project in China, which was in Tianjin. Tianjin is a small town in the east of Beijing, which is 12 million of people, connected with Binhai, and so it will make a small town of 30 million of people. So they are developing a lot, and they used that to make an artificial lake. So we were developing this idea of the folding through that, and using the same development of the steel plate. So these are not image anymore. This is the construction. So we had to fold this up and down again through the element, and which is like a cover for the bridge. And at the end, we are working with this idea of the void, because you're going to see in a minute another project in concrete that we did exactly on the opposite way. Here it's making mainly of the hole in the structure. transformation of the whole ribbon. Which is quite interesting, so that now we are more dealing with the idea that the steel industry can be transforming plates and not only bars. And we are developing our own relationship between drawing, calculation, and factory, because we are directly linked with the factory. We are giving our plants to the machine that will cut the steel. So it's another situation, very interesting, because the idea that the industry is coming to our office, or our office is in industry. And this is already done. It's not something that we will do in the future. It's like that already. So it makes sense to develop a very special way of cutting the steel. And just to finish, 5 minutes. Perfect. This is another bridge we are developing on the same. We develop on the same lake. And this, in that case, this was more the idea of using an element that will be reproduced in a continuum, and this is made out of concrete. So it was more like not a thin shell, but a shell. And the most difficult thing was to develop the scaffolding for that and the way to build it. So the idea that was mainly to give the illusion, because it's not real, that the bridge is like a floating bridge. It's like shells that are floating on the river, because on the lake, because the lake is not moving a lot. And it speaks about the idea of heaviness in relationship with the idea of floating, not anchorage, but suspended. This was the most difficult thing. We had to, as you see, we had to use this element 10 times. So the most difficult part was to develop a process to be able to reuse that element in many, not to destroy it each time. As it was, the lake was artificial. We used half of it to build it. And at the end, it's like that. So the idea of floating, working with gravity and weight was transformed in reality. These are not thin shells, but they are shells, which is quite... Thank you. There's one more slide. Just to tell you that next year in Paris there will be a congress on geometry and advance in geometry in architecture. So maybe you can come and join us, and I will try to be more theoretical that time.
Okay. Thank you very much, Mr. Mimram.